Hello everyone, my name is Adrenaline, the BAZUKA prophet, and today we're going to be working on a very interesting video which is talking about what we call the buffer system or the buffer solution. Now we should understand that in a layman term, the word buffer simply means to resist. And so therefore, in the field of physical chemistry, a buffer solution is one which is capable of maintaining its pH fairly constant even upon the addition of a small amount of acid or a base. So you should understand that. And that again too, a buffer solution is able to resist or to buffer in the sense that when we add small amount of acid or a base to the buffer solution, it changes, the solution changes very little even upon the addition of an acid, of a small amount of an acid or a base. Now, on that very note, we have two types of buffers, and the two types of buffers are: one, we have what we call the acid buffer, or also called the acidic buffer, and number two, we have what we call the basic buffer. These are the two major examples of the types of buffers that we can see in the field of physical chemistry. And now, an acid buffer. Now, an acid buffer is a buffer which consists of a weak acid. Please take note, a weak acid together with a sort of the same acid. Take note, two language there. It consists of a weak acid and its salt, meaning the acid salt, with a strong base. That is to say, when a weak acid is reacted with a strong when a weak acid is reacted with a strong base, it gives you the acid salt. And a very good example is ethanoic acid and sodium ethanoate, in which when this acetic acid is being reacted with a strong base, of course, this sodium is coming from a strong base. And secondly, a basic buffer, it is the reverse, or it is similar to an acid buffer, whereas in the case of a basic buffer, a weak base and its salt with a strong button, a strong acid. You can see here, you can look at it. So a basic buffer, a weak base and its salt with a strong acid. And your major and the very good example is ammonia solution with a salt. This is ammonium hydroxide with ammonium chloride. You see the way, you see the slash is, this is the base, this is the salt of the base. And on that very note, we should understand that a buffer solution can be used, we can calculate the pH of a buffer solution in the acid buffer and also in the basic buffer. And the equation or the formula we use in doing so is what we call the hasselbach equation, or simply say the Henderson equation, which in the case of an acid buffer, we have the pH is equal to the pKa plus log of the concentration of the salt over the acid. That is for the acid buffer. While in the case of the basic buffer, the pOH is equal to the pKb. Remember, we use Kb for the ionization constant of a weak base. The pOH is equal to pKb plus log reading of the concentration of the salt over the weak base, which is that of the basic buffer. And again too, when we are to go further, we should understand that the knowledge of a buffer solution is a very important concept in the field of the of acid and bases. And now in our next video, we're going to be talking about strictly on the calculations that are involved there. For now, God bless you.